Hello 3D printing friends. Today on the BV3D channel we're going to take a look at the new Artillery Hornet 3D printer. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. Hi, welcome back. Hey, if you're new here and you're wanting to learn about cool 3D printer upgrades, 3D modeling and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. The Artillery Hornet. Scientific name, Vespa artillery. This fascinating creature is easily identified by its yellow and black markings. It feeds on common materials, such as polylactic acid, which it uses to create nests. These nests can vary in size and can reach a maximum volume of 220 by 220 by 250 millimeters. Vespa artillery defends these nests with a potent, painfully hot sting, which can reach temperatures of 240 degrees Celsius. Okay, there's only so much of that I can do. The printer that we're talking about is the new Artillery Hornet 3D printer. This is the third 3D printer in Artillery's lineup, which also includes the Artillery Sidewinder and the Artillery Genius. The Sidewinder has a huge 300 by 300 by 400 millimeter build volume, a full metal case, touchscreen LCD interface, flex cables for a clean appearance, a main board with silent stepper motor drivers, and a direct drive extruder. And the Genius is a Honey, I Shrunk the Sidewinder with all the same features except that its build volume is 220 by 220 by 250 millimeters, and it introduces a bit of injection molded plastic for the top crossbar on the gantry. As for the Hornet, it's the same size as the Genius when it comes to build volume, 220 by 220 by 250, and it still uses silent stepper motor drivers. And it's got the Ultra Base style glass bed that Artillery likes to use, although the heating element on the Hornet's bed is driven at 24 volts by the power supply rather than 115 or 230 volt AC line power as it is on the Genius. But it's got a Bowden drive system instead of direct drive, although it does retain the geared Titan style extruder. And it's got a completely different aesthetic in the form of an aluminum extrusion frame with injection molded yellow plastic housings both front and rear. But with that, there are some cost saving measures being put into place. Instead of a color touchscreen, Artillery has opted for a more traditional 128 by 64 pixel graphical LCD with a clicky knob to control the printer. It also makes do without a filament runout sensor and only a single Z-axis stepper motor instead of the two you'll find on Artillery's other printers. And the end-stop switches are mechanical instead of inductive. Now, on the plus side, it's got a 32-bit mainboard running Marlin 2. And it has a cleverly simple X-axis belt tensioner where the Genius and the Sidewinder have none. The spool holder is low and front mounted, which is how I like mounting my spools when possible. It keeps the spool off the top of the gantry to minimize the possibility of the extra weight introducing vibration. It keeps the spool out of the way of the wiring, and you can quickly see how much filament you've got left. And it's got one particularly interesting innovation. The Bowden tube is merged with the hot end cables in a unique way, and we'll talk more about that in just a bit. So let's get this printer put together. In order to do that, we have to get all the parts out of the box, so let's do that. So first, there's some foam. Let's toss that. Oops, I'll clean that up later. Okay, this zipper pouch should contain tools and other stuff. We'll look at the contents of it in a little bit. Here's the spool holder. That's a nice injection molded part. This is the Bowden tube and the wires for the hot end, all in a single unit. That's pretty neat. And it looks like we've got a nice printed manual to go along with the printer. Can you guess what's behind this foam block? That's right, it's the hot end assembly. Let's get that out and take a look at it. Ah, cool. There's the Bowden/electrical connector at the top. You can see the heater block and a breakout board from underneath. And it's got a parts cooling fan here and here. And then, of course, the heatsink fan on the front. Looks nice. A little more foam. And then a few more things to remove, so let's get those out. Here's the gantry, which is already assembled, which will save us some time when we're putting it all together. Then even more foam. This thing's pretty well packed. Oh, whoops, here's a bolt. Where's that go? I guess we'll figure that out in a bit. Let's get the base of the printer out of the box. Oh yeah, isn't that nice looking? I really like the look of that. Oh hey, another bolt. I don't think these are supposed to be rolling around in the box. Okay, here's the power cord. And that looks like it. That's all the parts. Thanks for watching, everybody. I'll see you next time. I'm just kidding. I do think I found where those bolts are coming from. It looks like there's supposed to be 2 of them on either side for a total of 4. Now this one makes 3. And I've located the 4th one. It's managed to sneak inside the rear plastic housing. That's going to be fun to get out. Give me just a second. Hang on. Almost. Almost. Ah, haha, finally. There we go, free at last. Okay, so now that we've gotten those 4 bolts found and set aside, let's take a closer look at a few things. Here's that zipper bag that was about the first thing out of the box. It contains a USB cable, a really nice 8mm and 10mm wrench, a bag with Allen keys and a few small screws, which I think are for attaching the hot end to the X carriage, and a bag with the micro SD card, full-size SD card adapter, USB card reader, zip ties, spare tires, and a spare nozzle. Now, here's that unique Bowden tube and cable combination. The Teflon tube runs through the center of it to deliver filament to the hot end, and the electrical connections surround the tube. It seems to do a good job of distributing the flex, so hopefully the conductors within it are unlikely to break as a result. But still, it's likely to be a consumable part. It might be a good idea to buy another one from Artillery to have one on hand in case you need it. And here's another bit of interestingness. The Z-axis stepper motor is mounted at the top of the gantry. Why? I have absolutely no idea. And just so you can get a good look at them, here are the 4 M5 bolts that we'll use to attach the gantry to the base of the printer. Before we go much further, let's talk about the manual. Artillery has a really nice printed manual for the Hornet. It's pretty clear about how things go together. It covers assembly and wiring, which is easy because there are only a few connectors to plug in. It also covers adjusting the eccentric nuts on the V-slot wheels and leveling the bed. The bed leveling bit is surprisingly detailed, in fact, and it covers how to set up the Cura slicing software for use with the Hornet. It walks you through adding a custom printer, setting the correct values for the build volume, importing a trio of Hornet-specific printing profiles, and even covers how to copy and paste the necessary starting and ending G-code from a pair of text files included on the SD card. The SD card also has a Windows version of Cura, but no Mac version. The manual does at least indicate that Mac users can go download Cura for free, but they don't provide a URL where you can actually download it. Honestly, why not just include the Mac version on the card? There's plenty of room there. Also on the SD card is an Artillery Cube model, both as an STL file you can slice and print, as well as a pre-sliced one in G-code format that you can use as your first test print. And we'll print that one later after we've got the printer assembled and set up. So with that, it's time to put the printer together. And to get the Hornet assembled, there's really not a whole lot to it. We'll bolt the gantry to the base with 4 bolts, then bolt the hot end assembly onto the X carriage, and then finally we'll connect all the wires. Let's go ahead and get started with that. The 4 M5 bolts, which are used to secure the gantry to the base, only have threads on the end, not the middle of the bolt. As I mentioned, these were pre-inserted into the base before they worked their way out. The holes in the base frame are threaded, so the bolts are screwed into them. The part of the bolt that doesn't have the threads is a smaller diameter, so once they're in, they can spin freely. And this would have been great, but as you saw, 3 of the 4 bolts worked their way out during shipping, and 1 got into the back section of the printer. Now, in retrospect, it was kind of funny, but the back half of the printer is where the power supply and the main board live. If the screw hadn't rattled, and I assumed it hadn't been included with the printer, it could have been a big problem if something shorted out when I turned it on. So I recommend that Artillery ship the bolts in the zipper pouch with the tools so the bolts don't escape. I mean, I know this was intended to be a time saver during the assembly process, but since I had to play hide and seek with 3 of them before I could assemble the printer, no time was saved. So, first thing, let's get the gantry bolted to the base. It'll go like this, with the Z-axis limit switch on the right side of the gantry facing forward. Tighten each bolt until it's just barely tight and then back it off a bit. Set the printer back on its feet. Yes, the gantry is still a little loose. I want to make sure that the uprights are properly spaced when the X-axis arm is at the bottom before fully tightening the bolts. So, cut the zip ties that are on the gantry. Then manually turn the Z-axis stepper motor to lower the X-axis arm down to the bed. Keep an eye on the Z-axis limit switch and stop when you get down to it. Now we can tighten those 4 bolts to secure the gantry to the base from below. It won't take much to do. While the printer is on its side, let's take the opportunity to adjust the eccentric nuts on the Y carriage. There are 2 of these located on the right side of the carriage. So what I'm going for here is having the wheels just tight enough against the aluminum extrusion that they take a bit of force to turn by hand. They shouldn't be super easy to spin. Freewheeling is definitely the opposite of what we want. They need to be tight enough that the Y carriage and the bed don't wobble. So use that nice wrench included in the kit to turn the eccentric nuts if the wheels need adjustment. And as you turn the nut, the wheel will move closer to or further from the extrusion. If the direction you're turning it makes the wheel looser, just turn it the other way. It might take a little bit of back and forth to get it to feel just right. Oh, and while we're here, make sure the voltage switch is set to match your electrical system, either 115 or 230 volts. Then set the printer back on its feet again and we'll check the wheels on the X carriage. If they feel like they need adjustment, perform the same steps. The wheels here are in a triangular formation, and in this configuration, the one with the eccentric nut is usually that lonely 3rd wheel. So in this case, it's the one on the bottom. Also, check and adjust the wheels on either side of the X-axis arm if necessary. Now, they may not always need adjustment. The next step is super easy. Attach the spool holder. No tools needed for this one, it just snaps into place. Now let's attach the hot end assembly to the X carriage. It's held in place by 3 screws. So line the hot end up with the X carriage and insert the screws. But don't tighten them all the way until you have all 3 of them in place. Then go back and tighten the 3 screws. Next, the wiring. We'll start with the Z-axis stepper motor. Plug the 2 connectors together. They only go together one way. Then plug in the Z-axis limit switch. Then plug in this cable, which runs up to the X-axis. It plugs in under the X-axis stepper motor. Finally, we'll plug in that unique Bowden tube and hot end cable combination. This notch aligns the cable with the connector. Push the Bowden tube down into the hot end. With the cable aligned, tighten the metal ring to secure it. Follow that same procedure to connect the Bowden tube and cable to the connector here. Oh, one last thing. If the X-axis belt is a little bit loose, there's a belt tensioner. Turn it to tighten the belt as needed. And hey, it's all put together. Awesome! As I mentioned earlier, the manual's got some really good instructions for leveling the bed, so let's run through those steps now. With the printer on, select Temperature, Preheat PLA, Preheat PLA. This will get the bed and nozzle up to operating temperature. Once they're up to temp, let it sit for a minute or 2. And this will give the temperatures a chance to stabilize. Be ready with a piece of paper. I'm using the quality checklist that came with the printer, but 2D printer paper works just fine too. Select Motion Level Corners. This homes all 3 axes, then moves the nozzle to the first adjustment point. As the nozzle is moving, keep the paper between it and the bed. When the nozzle lands at the first corner, adjust the knob on that corner until the paper slides between the nozzle and the bed with just a little bit of friction. Click Next to move to the next point. Keep the paper under the nozzle as it moves and adjust that corner. Repeat this for the remaining corners and for the center of the bed. It's a good idea to keep clicking Next to go around the bed 2 or 3 times because adjusting one corner can affect the other 3. When you're done, click Done to finish. When you start your first print, you may need to fine-tune the knobs to get it really dialed in on the first layer. If you need to adjust them on the fly, adjust the knobs a little bit at a time and be careful doing that when the printer's moving. You don't want to get pinched or burned or anything. Oh, and check out Billie Ruben's infographic about bed leveling. It's by far the best guide that I've seen about what a good first layer should look like. I've got a link to her infographics in the description. Click that and scroll down to the bed leveling guide. So, speaking of first prints, here's a time lapse of that pre-sliced artillery cube. I printed this in a marble PLA and I think it came out pretty good, and there were no obvious problems with it. The layers seem pretty consistent without any layer shifts. I followed the steps in the manual to configure Cura and print a few other files as well. I used the Hornet normal profile to slice these. I printed a stringing test and I was super impressed. There was absolutely 0 stringing on this, none at all, and consistent column widths on both columns of the model. This was using that same marble PLA that I used for the artillery cube. I printed a Calicat and it came out mostly okay, but I noticed cooling issues on the 45-degree angle part of the tail, along with a few strings. Not many, but a couple. The overhangs weren't cooling fast enough and they started curling up. I'm pretty sure that the strings are a result of the nozzle dragging through the parts that curled up because they seem to only be on the same layers where that curling was happening. I also printed a benchy, this time using Printed Solids Jessie PLA in the red ice color, and it too came out mostly okay. It's got the usual little spots that I associate with a Cura sliced benchy here on the side of the hull, but no stringing, which is really nice to see. But that cooling related issue that I saw on the Calicat is also presenting here on the lower part of the bow. The print was curling up a little on these parts because it wasn't cooling fast enough, so that shows up as this rough area here. So then I printed Luby's Aria Dragon in red ice, and the parts cooling issues persisted. You can see them here in the overhangs on the chest and the belly, and you can see it here on the trailing edge of the wing. And the tips at the top of the wings didn't do well at all. So I took the card and the filament from the Hornet and loaded them both up on a stock Ender 3 V2. Now they've got the same build volume and they both have Bowden feed systems, so it seemed like it would be okay to do that as a cooling test. And while there were a couple of serious under extrusion issues on a couple of the layers, the areas where the Hornet had trouble with cooling came out a lot better when printed on the stock Ender 3 V2. The chest and the belly came out much better, as did the trailing edges of the wings. And the tip-top of the wing tips came out in tip-top shape. And from what I can tell, despite having 2 parts cooling fans, the Hornet just isn't good with cooling. Looking at the parts cooling blower output of the Ender 3 V2, I see that it narrows down through a duct to sort of focus that cool air right where the nozzle is. Looking at the blower outputs of the Hornet, there isn't really any ductwork. I mean, the sides of the hot end housing kind of direct the air toward the general vicinity of the nozzle, but it's not focused, and I think the air just isn't going where it needs to go to effectively cool the filament as it's being laid down. Now, just for fun, I did print a large object in vase mode. This is a faceted rose vase I found on Thingiverse a long time ago. I scaled it up and I printed it and it came out really good, probably because there aren't any real severe overhangs. Also, on a whim, I made a cube in Tinkercad to represent the entire build volume of the printer. Now I ended up having to scale it down just a bit to get it to fit in Cura because it had to accommodate the skirt, but basically this is the entire build volume of the printer. Now I've seen other folks do this and it seems like a great way to get across the concept of how big of a thing you can print with any given printer. So if the model that you want to print will fit inside this box, you can print it on this printer. Interestingly, the sides got a little bit wavy. They were supposed to be smooth. Now I think that's from the stresses of the filament cooling and gently warping the model. Now the base of it stayed down on the glass for the most part. There was a tiny bit of curling up at the corners, but nothing major. And I think that has to do with the fact that the edges of the bed, particularly the corners, don't get to quite the same temperature as the rest of the bed. So now that you've seen how to assemble the printer and some of the prints and the quality of them, I'd like to share some of my observations about the Hornet. The hot end fan is a small one, 30 millimeters in diameter. It's controlled by the main board and it only turns on when the hot end is above about 50 degrees. Now this helps keep the printer quiet. Unfortunately, it's a cheap fan and the bearings or the bushing wore out after only a few days of printing. So now it makes a buzzing noise when it starts spinning. Yes, the printer is called the Hornet, and yes, the one I have buzzes angrily. Anyway, I have to poke the hub of that fan with my finger to get it to stop doing that. Now the fan at the back of the printer, which cools the electronics, runs while the printer is on. It's a little bit loud, but it's a lower pitched whoosh noise, so it's tolerable. The power supply's fan is on full time when the printer is turned on too. Its fan blows outward, so with the way the power supply is oriented, it's blowing down onto the surface that the printer is resting on. Now the gap between the power supply and the work surface is about 5 millimeters. I don't know if this restricts airflow to any great degree, but the gap could be easily increased by using taller rubber feet on the printer. As I described when showing off the prints, despite having two parts cooling fans, parts cooling is inadequate. I can print the same file with the same filament on an Ender 3 V2 and the parts cooling is much better than when I print that file on the Hornet. The Hornet doesn't have a silicone sock on its heater block. Does it matter? Well, it might. If parts cooling fans have a better ducting to focus their airflow near the nozzle, the printer might have to fight against that added airflow to keep the heater block and the nozzle at the target temperature. If you want to put this printer in an enclosure, be very aware that the Bowden tube and cable combination makes this thing a lot taller than something like an Ender 3. Also note that the gantry on this printer is a lot taller due to the Z-axis stepper motor being mounted at the top. Now the bed springs are the good yellow kind that I like, and I find the printer's aesthetics to be pleasing. To me, it looks nice. I like that pop of yellow with the black frame. And the hot end fan shroud shape kind of reminds me of a Hornet's face. Now I want to come back to the manual again. The manual included with the Hornet is, to me, one of the best manuals I've seen included with a 3D printer from China. The English used in the manual reads smoothly, and I think Artillery has done a pretty good job with this one. The manual has clear instructions walking a user through the process of leveling the bed. It also does a phenomenal job of walking a user through the process of configuring Cura, covering how to add the printer, what values to set, and what checkboxes to check. It also shows you how to import the printing profiles included on the card, and how to select them, and how to slice a file, and how to save it to the SD card. The manual covers all that in a beginner-friendly way, but then it doesn't actually cover putting the card in the printer and selecting a file to print. Now, as good as it is, the manual does need to cover printing from the card and the filament loading and unloading process. I also think a page or two showing the entire menu tree and a description of what each item does would be an awesome addition to the manual. So that's the Artillery Hornet. It's easy to assemble, 4 bolts for the gantry, 3 screws for the hot end, plug in 4 things, and you're done. It looks nice, but it has trouble with parts cooling. It does away with the direct drive extrusion system and flex cables that the Sidewinder and Genius are known for, and introduces a Bowden drive extrusion system with a unique tube and cable combination. Now, how well that Bowden tube and cable combo hold up in the long run remains to be seen. I'd like to see Artillery come up with a fix for the parts cooling issue on the Hornet. It may be as simple as designing a duct to fit in the output port of the blowers to better direct the airflow, but as it stands out of the box, parts cooling is a problem. Now, if Artillery can fix the fan issues, both the hot end and the parts cooling fans, this will be a nice printer that's easy to assemble and get up and running. The firmware on this unit is Marlin 2.0.7.2, and I've had no issues with it at all. Interestingly, the Hornet does not have the resume printing after power outage feature that a lot of printers now have. I checked Artillery's site and all three of the printers appear to be on sale. The Hornet is priced about $40 less than the Genius if you look at the sale prices in red. If you look at the crossed out prices, which presumably are the full retail price, the Hornet is only $10 less than the Genius. So is the Hornet worth the slight savings over the Genius? Well, the build volume is the same between the two, but the Genius gives you dual Z-axis stepper motors, a direct drive extruder, a color touchscreen, filament runout sensor, and the ability to resume printing after a power outage. The Genius has a lot of extra features for just a little more. So it may come down to personal preference and what features are most important to you. The Hornet certainly has a unique appearance and an innovative Bowden setup. I honestly don't know all the factors that go into deciding the price of a 3D printer. I'm on the outside looking in, but to me, it seems that the pricing of the Hornet is too close to that of the Genius, so it's not clear to me where the Hornet sits in the product lineup. Is it positioned at the same level as the Genius with a slightly different feature set? Or is it intended to be Artillery's entry-level printer? I'll leave it to you to decide if the money that you save getting the Hornet instead of the Genius is worth that difference in features. There's a link to Artillery's site in the description if you want to check it out. Now, I think I've covered everything that I wanted to cover. If you have questions about the printer, leave a comment and I'll do my best to answer it. Well, 3D printing friends, that's about all the time we have for this episode. And now that we're at the end, let's go print something cool. Hey, real quick before you go, I wanted to say thanks for being one of the super awesome people who sticks around all the way to the end. And thanks for all the likes, comments, and shares. And an especially big thanks to those who directly support what I do. You're all wonderful for doing that, and I really appreciate it. If you liked this episode, a thumbs up would be great. And if you'd like to help support the channel, check the description for ways you can do exactly that. Oh, and I've got some other videos here that you might want to take a look at too. And if nothing else, please consider subscribing if you haven't already done so. It's absolutely free, and it's an excellent way to help keep me making these videos for you. Well, that's it for this one. Thanks again, and I'll see you next time here on the BV3D channel.